Hey, this is Ryan at PlanetTogether. Thanks for joining us on our webinar today. Here's a recording for you to share with your team. If you have any questions at all, feel free to contact us. Thank you for joining today. Our webinar is on lean manufacturing this morning. We're going to discuss how planning and scheduling software can help you minimize those traditional lean manufacturing wastes. And give a little bit of the format and outline of the webinar. So yeah, we're going to do a 30 to 40 minute webinar this morning. I'll do some introductions. We'll give you a brief history of lean. Who doesn't want that? And then we're going to have a nice little lean and planning and scheduling section where our two panelists are going to have like a back and forth round robin discussing a lean waste and how planning and scheduling software can help reduce that. And to sum it up, we'll go over some metrics and some performance points that you can expect to achieve if you did implement a planning and scheduling software system. After that, after the webinar section, we'll do a live Q&A for about 10 to 15 minutes. And so during this section, you'll see in your GoToWebinar control panel, you'll see a little hand that you can raise. So we'll open it up for live questions at that point. If you do have questions during the webinar, you can enter them into the little questions area onto GoToWebinar, and we can queue them up and take them as they come at the end. So let's get started with our introductions. Our first presenter, or our first panelist, rather, is Kenta Tamura. He has been with PlanetTogether for over 6 years and has done many deployments of planning scheduling software. He's saying 20 to 25. I think it's got to be more than that by now. Alone, Kenta supports over 100 clients for us, and that includes over $5 billion of annual manufacturing production revenue. Some of the sectors he works in are manufacturing, automotive parts, consumer products for discrete manufacturing. And in the area of process manufacturing, he's been involved with food and beverage implementations, chemical, metal alloy machining, and construction. So he's an expert in the field, and you'll get a lot of good content from him today. And our next panelist is Bob Lane. He is president and founder of Lane OPX, Operational Excellence Company. He's an expert in lean manufacturing and operations. He's been involved with the turnaround of 6 companies personally. He has over 30 years experience in the area. He's been all over the world. He just recently got back from Europe for about 3 weeks. And on the side, he also is an instructor for APS here in California. And he's a recognized public speaker at the local universities, and he acts as a mentor and coach for university students as well. So there's our introductions today. Sit back, enjoy this webinar, come up with some good questions for us, and I'll turn it over to Bob.
Well, I'd like to say good morning and good afternoon to all the participants on this webinar, and also thank you for attending. It's my pleasure and privilege to talk on the subject of lean manufacturing and the new paradigm, how transactional lean and the application of advanced planning and scheduling is transforming factories. But first, I'd like to start off with lean, a brief history. This particular slide that you're looking at is a slide I've used worldwide in probably about 24 keynote speeches regarding lean manufacturing and how to optimize a shop floor. So let's just take a quick look at it, and let me read the quote to you from Henry Ford. The quote says, "The longer an article is in the process of manufacture and the more it is moved, the greater its ultimate cost." I think if we just step back for a moment and digest that quote, we can clearly understand and recognize that the longer it takes to produce something or do anything in your life, the more it's going to cost. Remember, time is money. So what you're going to be learning today is about the waste inside lean. There are traditionally 7 wastes, and we've added one that we're going to talk about, and how advanced planning and scheduling will help you reduce that time to excuse me, to manufacture product and better align with your supply chain. So before we dive into the power of the presentation, let's take a few minutes and look at a brief history of lean, where it started and where it's heading. I think this is a really important slide for everyone. So starting all the way on the left, you'll see Eli Whitney around the 1800s. In the United States, Eli Whitney was very famous for inventing the cotton gin. That's what he's known for. But in reality, when you look at the work he's done, his body of work in his career, it really tied into interchangeable parts, or what we call standardization. And he recognized that if you could build products off of a standard chassis and with standard components, you're going to produce them more efficiently, more effectively, and obviously with better cost efficiency. And from Eli Whitney's time in the mid-1800s to the early 1900s, there were two famous industrialists named Frederick Taylor and Frank Gilbreth. These two gentlemen, in essence, are known as the fathers of industrial engineering. And what they did in their work and their studies is they focused on standardized work, time and motion study, process charts, process improvements, all based on the foundation of standardization and how to optimize demand, meaning the resources, with manufacturing of products. And that was the foundation for assembly line production. And then in the early 1900s, slightly after Taylor and Gilbreth's work, Henry Ford came along, and of course you guys have all heard of Henry Ford and the work he did with the assembly lines. And he focused on flow line manufacturing and manufacturing strategy to just keep that line moving and reduce waste. His system allowed for high volume production and standard products. Now, in the old days, for example, when Model A's and Model T's were being produced, they were very limited car models, so very limited changeover and setup on the production lines. So assembly line manufacturing in a simple model worked out very well. Now, in the mid-1940s, as everyone knows on this call, we had World War II, which was obviously the greatest war in the history of the world, and that war took quite a toll. Over 45 million people were killed in the war, and Japan's economy was decimated, and along with that, factories in Japan were destroyed. And through a program called the MacArthur Plan that was led by the United States, it was decided through a very large collaborative effort to rebuild Japan economically, but not militarily. And in the early 1950s, Toyota started to really develop as an automotive manufacturer. And of course, today, Toyota's usually one or two leading the world as an automotive manufacturer. So three gentlemen, Mr. Toyota, Mr. Ono, and Mr. Shingo, led the development of what we now know as TPS, or the Toyota Production System. And the Toyota Production System was based on the concepts of just-in-time, stockless production, meaning don't hold inventory, minimize raw material, minimize WIP, minimize finished goods, and of course applying a great focus on quality to generate world-class manufacturing. And here we are, many years later, and Toyota still leads in quality surveys. So I'm going to repeat this. In the 1950s, as Toyota really started to develop, three gentlemen put a large focus on what we today call lean manufacturing. And they introduced concepts of Kaizen, meaning continuous improvement, and created TPS, the Toyota Production System. And as the world economy grew from the 1950s to about 2000, globalization, or global manufacturing, became more prevalent. The U.S. was not as strong as a worldwide economic leader. We're still number one, but our edge has been slipping as other countries and other global companies have really been developing. And they've been developing for many reasons, but for the purpose of today's discussion, the application of TPS, or lean manufacturing, contributed quite a boost to their ability to produce efficient products, high quality products on time. So now that the world has become a lot more globalized, there's tremendous competition from Asia and from Eastern Europe, of course from China. There's a new paradigm taking place, and that's called lean transactional, where there's now more focus applied to what I call the systems, the methods, the processes. And this is where lean scheduling, or APS, kicks in. So key purpose of today's presentation is Kent and I will share the integration and the crossover and the benefits of focusing on lean transactional, lean scheduling to help take your companies to the next level.
So before getting further, I'd like to first introduce the concept of advanced planning and scheduling. So as a PlanetTogether, we offer and implement an advanced planning and scheduling system. What it does is we take data from the ERP system, which usually acts as a hub of all information concerning manufacturing, and we contribute to capacity planning using actually available capacity, optimize shop floor scheduling based off of various physical constraints that are out there on the shop floor, and we improve inventory visibility and planning by reducing inventory, things like WIP, finished goods, and synchronizing the procurement planning. And so out of here, we also provide things like predictive analytics based off of the forecasted schedule to really act as a link between the transactional information versus the manufacturing, the physical world of production floor.
So in the world of lean, traditionally there are 7 wastes that are associated with lean. These are the wastes of overproduction, the waste of waiting, the waste of transportation or logistics, excess processing, the waste associated with defects or poor yields, the waste of motion, and the waste of inventory. So what we're going to be doing today is really diving into these wastes, these traditional 7 wastes, and showing you how applying advanced planning and scheduling can make quite a difference to lean out these trouble areas. However, before we dive in, I want to express that we're going to be sharing an 8th waste, which you'll have to wait 7 more slides before you see it, because there's an 8th waste that makes quite a difference on the shop floor. So anyway, regarding the first waste is overproduction. And I think just simply stated, the name speaks for itself. In the world of manufacturing, to run an optimized plant, it's so important to balance supply and demand. You don't want to overproduce, and of course you don't want to underproduce. So with that said, I'm going to start some dialogue with Kenta, and Kenta, maybe you can share how advanced planning and scheduling can help improve the balance of supply and demand.
Okay, absolutely. So the system already knows for each demand when it ought to be shipped. So it's just really a matter of when is the best time to release these orders into the schedule in order to minimize overproduction, or best scenario, eliminate it altogether. So through automated scheduling that we call optimization, we can really minimize the time, the gap time, or the buffer between when an order would be completed or scheduled to complete versus when it should really be shipped. So through optimization, we can really create a just-in-time schedule that minimizes overproduction.
Fantastic. You know, when the Toyota production system was established in the 50s and still practiced today and continually practiced, one of the tenets of it was just-in-time.
Mm-hmm.
And how can just-in-time scheduling help reduce inventory in the system?
And so the key thing is, only producing when you need to, not because of this belief that you need to keep the machines running. So the system can calculate based off the demand how long each demand is going to take to produce, when it needs to be released in the schedule in order to complete right on time.
Okay, fantastic. What I'd like to express is today we're just going to touch upon an overview of the 7 wastes, and then we're going to add an 8th waste. But we're completely open to feedback because we have webinars on each of the wastes that go into a lot more detail on how scheduling can make a big difference in your lean environment.
Mm-hmm. Right. And I think one thing I'd like to add is, in addition to the automated aspect of scheduling using a PlanetTogether advanced planning and scheduling, there's the user aspect of when they're making decisions as to whether to expedite an order or not based on customer demand, really see visually whether they're making the right decision or not.
So it sounds like what you're saying is data-driven lean improvements.
Right, right. So as you're making decisions, either through metrics or for visual aid, you're really making fact-based decisions rather than intuitive decisions.
Okay, fantastic. So why don't we take a look at the next waste? So the second waste is the waste of waiting. And in this particular graphic, you see 3 people waiting, and we all know the pain of waiting, whether you're waiting at the doctor's office or you're waiting for an ice cream or you're waiting for something to come off the shop floor. And waiting is time.
Right.
So how does scheduling software help reduce waiting time and, in essence, save time?
Right. So in a world where you're stuck to using a spreadsheet or whiteboard, you really have no visibility as to the relationship of various work orders out there that have interdependency, whether it be multiple operations or web items. And so with a system like advanced planning and scheduling, you really get to see the visual relationship, the interdependency, whether it be materials or process, especially machine shop operations. You really have, down to 14 operations, 15, and so forth. We really need to sync them all together so they all flow in a non-stop manner. So through the use of optimization, you can set a priority to make sure to minimize the idle time between operations.
Okay, fantastic. So the scheduling software and the data-driven analytics that are part of the software, does that help with quick decision making?
Absolutely, absolutely. And it'll guide you in the right way in that the longer you increase the waiting time or the idle time, that obviously leads to longer lead time for any product. So through, the use of predictive analytics, really get to see it promotes the behavior of continuous improvement.
Okay, fantastic. Why don't we go ahead and look at the next waste? So the third waste in the lineup of lean waste is the waste of transportation. And when we think of transportation, we have to think of it as multidimensional. There's the inbound supply from suppliers. There's the handling and transportation within your facility. You might have multiple buildings or multiple plant locations. Then there's the shipping and logistics to ship to your customer. And
right.
One of the common pain points across manufacturers worldwide is expedited shipping. Sometimes we have to pay expedited shipping with suppliers, and we might be paying expedited shipping to ship to our customers. So can you share how improved scheduling can help reduce the hiccups in transportation and transportation costs?
Absolutely. So with the schedule that's accurate, that you can depend upon, you also be able to share that sort of the forecast, an accurate forecast, with your suppliers as well. So then suppliers are also in sync with what your requirements will be from the raw materials or component standpoint.
Okay, great. So, in manufacturing, whether it's my plant or the suppliers or even the customer, there's a lot of uncertainty that takes place. Sometimes the demand changes, the customer changes their order request,
right,
or a supplier can't meet the demand to fulfill the parts order. So how can the APS system and the analytics and reports from the system help with uncertainty?
Right. So a lot of the pain points without a system like this is that information is usually verbal or in paperwork, so it's not really treated as a piece of data that's critical. With a system like this in place, as long as the information is entered, and let's say an ERP system, that's usually common practice, then we immediately seamlessly bring that data in to update the schedule. So if a customer changes their mind regarding the ship date and decides to push the order back, we'll see that right away visually. If your vendors decide to push back the receipt dates, in other words, the date in which their parts will arrive to the shipping dock, we'll immediately see that in the schedule. So you avoid situations where you release orders to the shop floor and find out there are not enough parts because no one was communicated about the fact that the vendor will be late.
So if I'm running a manufacturing facility and I'm able to smooth out my scheduling and better know when products will be completed.
Mm-hmm.
Can I translate that information to better forecasts for my suppliers?
Absolutely. Absolutely.
Okay, thank you. Why don't we go ahead and look at the fourth waste? So the fourth waste is excess processing, which can be looked at in many lights. But unfortunately, sometimes parts or products are handled too much, or we have to go back and do some rework, or there's some excess processing that takes place. Sometimes we excess process because our routings are a bit uncertain.
Mm-hmm.
And this has always been really confusing to me. How can a scheduling software help reduce excess processing?
Mm-hmm. There's many ways to capture the routing information. Sometimes it can go through the same set of machines, but with each machine, the process time could be different, the practice could be just a little bit more different in a way that ultimately people intuitively know this is the best machine to handle it, but it's more based on intuition rather than data. So with advanced planning and scheduling, we can really set a rule for the optimization to always pick the best process so that the way that the system schedules will always based off of choosing the best routing or to the best machines.
Okay, so it's interesting. You said the word rules, and that opens up some questions in my head. If I'm the CFO or the plant manager, and I really want to maximize revenue this month,
Mm-hmm.
and that means I look at which customers will bring in the greatest revenue,
Right.
or which products have the greatest margin. Can we set up scheduling rules to help me optimize what I schedule to maximize the revenue for a given time period?
Right, and thank you for bringing that up, because one of the optimization rules we do have is this idea of throughput hours versus the revenue. So we look at basically the relationship between how long it takes to produce a part versus the revenue associated with that part or the product, and really prioritize towards maximizing that metric.
Understand. So in the world of lean, excess processing obviously is a waste, and what you're saying is if we set up the rules on how we want to operate our plant, naturally that's going to reduce excess processing.
Exactly.
But we could take it to the next level and optimize our revenue.
Exactly.
Okay, thank you.
Mm-hmm.
Let's go look at the fifth waste. So the fifth waste is the waste of defects. And unfortunately, a number of companies don't even track defects. It's we look at defects, and defects can be caused by the operator, the worker. Defects can be caused from defective parts,
Mm-hmm.
or defective assemblies, or maybe defective process. A machine's not operating right, or
Right.
a certain process was structured wrongly. So defects oftentimes are hidden because it's revealing, and sometimes it's personally revealing, and it's a challenge to find the root cause. But if a factory is able to understand their defects, how do you take that into account when you're trying to schedule in a lean manner?
Mm-hmm. And really there's two aspects to this, and like you mentioned, there's an aspect where we want to capture your yield on the floor. Mm-hmm. So if you're supposed to produce 100 units and it took 120 to get there, or you may say only produce up to 100 and 20 happen to be scrap. So you want to capture the actual yield rate and continue to track that through analytics in order to analyze what your yield rate is going to be. Mm-hmm. And the second aspect is using a planning scheduling system. You want to account for the yield and make sure you have the right amount of time and material allocated for each of the work you do. So you're embracing and anticipating that scrap that's going to happen.
Thank you. Kenta, in the last 4 months, I came back from 2 large international trips. One was in Asia, and one in Europe, and 2 in Europe. One was in England, and one was in Europe. And it was very interesting. In these manufacturing facilities, the planners or schedulers were just using Excel,
mm-hmm.
and they were editing last month's Excel chart, and they were looking at output that came out of the sales and operations planning meeting. But they had no data regarding really what's going on in the shop floor,
mm-hmm.
such as yields and defects. And what can really help the audience is if you explain how the PlanetTogether APS grabs the data
mm-hmm.
from the customer's facility,
sure.
so you can assemble your predictive
mm-hmm.
analytics.
And I know you're probably far more expert on this, but as far as shop floor practices, it's probably a common thing for production to track, what was reported as being good quantity versus scrap, correct? Is that a correct assessment?
Sure.
And because a lot of the information, whether it be, it could be on a piece of paper or through barcode scanning, it's maintained somewhere, either Excel or ERP system. So we really just, back to the original point with regards to how advanced planning and scheduling works, we leverage off of your ERP or Excel data to bring those information in. So then we can capture the standard versus the actuals. So if you were supposed to make 100, what was the actual outcome? Did you actually produce 100 good, in addition to the 20 scrap that came in with it, and so forth?
So are you saying the PlanetTogether software, in essence, is integrated into the ERP system and
Exactly.
pulls the data?
Right.
And then with that in essence drops into your suite of analytics?
Mm-hmm. Exactly.
Okay, understand. Thank you. Well, let's go ahead and look at the sixth waste. So number 6 is waste in motion. And in the Japanese culture where Toyota production system evolved, there's a famous term called mutadori, or it's a waste of motion,
Mm-hmm.
Waste in motion. And when we apply the initial principles of lean to smooth out a factory and allow it to be more efficient, we focus on mutadori, or waste in motion, and it's excess work we shouldn't have to do, right? So how could a lean APS help reduce motion on the shop floor?
And a lot of it has to do with sort of the transactional aspect, the lack of communication or the lack of visibility or lack of common information. And so with a system like in place where it's a multi-user platform, every functional level within the organization will have benefit and access to the information to see whether it be procurement, customer service, the manufacturing, knowing what they need to produce next, or the top level management people having the high level visibility into the performance of their manufacturing environment.
Okay, I understand. So how do we know non-value versus value add? In the world of lean, we do what we can to reduce non-value operations and focus on value add. We go through exercises like spaghetti diagrams and value stream mapping to try to find those non-value or those costly activities that are not applied activities. What type of data analytics do you have to help a plant separate out the two?
And so I think a lot of times the ERP systems will have a lot of the financial data, the customer information, and so forth. What they often lack is the true information of what's actually happening on the shop floor. So PlanetTogether Advanced Planning and Scheduling as a hub of all those information together, again, acts as the link between what is actually happening on the shop floor and manufacturing side, as well as the financial and transactional side. Both combined together will give you information like, what is the throughput per dollar, or what is the cost of running various orders out there, and gives you the delta, in other words, profit or the lack of profit.
And thank you for sharing it. I think this is a waste that we should stay on for a moment. It's really important. I'm supporting the integration of PlanetTogether APS for an advanced machine shop in San Diego. They're heavily involved in producing medical device products and aerospace products, etc. And what's really interesting is a very strategic decision to kick off a major lean initiative at the same time PlanetTogether was being initiated or orientated into the business. And the principles that we put forward were the data coming from the PlanetTogether system and the changes in scheduling, as we head towards optimization. They became the visual points for our CI, the continuous improvement program. And I think you're seeing that more and more, that companies can utilize the information from PlanetTogether and see the changes in schedules to know where to focus to apply continuous improvement activities.
And previously, there seems to have been belief that a system like a planning and scheduling system can only be benefited by a planner or a scheduler. But I think it's obvious that that's not the case. It's really a system that every functional level can really benefit from and be driven using a common system.
Very well said. I know this particular company, the decision to apply APS to their lean program was voted on unanimously by the entire executive team as well as the board, because the decision was made to use it as an enterprise-wide initiative, and it creates an amazing focus on where to apply continuous and lean activities.
Correct.
Excellent. Why don't we go ahead and look at the next waste? So the next waste is waste of inventory, and what I'd like to suggest is, and I certainly have seen this from all my travels around the world, companies that produce products, manufacturing companies, within their cost of goods sold, which is labor, material, and overhead, the material or inventory component typically makes up 60 to 65% or greater of the cost. So what we like to say is the majority of costs in manufacturing are tied to inventory and then the labor to support it. Of course, some highly automated facilities like an Intel processor plant, a lot of cost is tied up in capital equipment. Those are billion-dollar facilities. So I think it's really important that we spend a few minutes and discuss how good scheduling based on plant-driven priority rules, can really reduce inventory costs.
Right. So I have a consumer product a manufacturing company, one of my recent client of mine, and they have had trouble in the past because of a lack of an effective planning and scheduling system. They would either often run out of the raw materials, or they would often purchase too much in anticipation of not knowing what's happening. So with using an advanced planning and scheduling system like PlanetTogether, they know exactly when they need to produce when, so that kind of ties into the overproduction side of things. But not only that, they know exactly when they need to procure those raw materials in order to align with their supply and demand.
It's very interesting. We earlier talked about the waste of waiting. Waiting can also be associated with downtime. And in most manufacturing facilities, the number one cause of downtime is lack of materials. Doesn't mean every part on the bill of material is missing. It could be just a washer or a cotter pin or what have you. And this advanced machine shop that we're working with, we're providing reports from the PlanetTogether system to the suppliers so they can be better aligned with the supply they have to provide, because inventory not only is a problem if you have too much, it's a problem if you have too little. It's also a problem if you don't have it at the right time.
Exactly.
Right? And excess inventory leads to slow inventory turns, which screws up a company's cash flow.
Right.
So do you find that CFOs are typically champions of an APS system that will help them improve their cash flow?
Right, exactly, because it ultimately leads to improved inventory turns, reduce inventory, things like raw materials, work in process, as well as finished goods, because you're not producing things that are just going to sit in the warehouse until they get shipped out eventually.
It's interesting. COOs, CFOs, plant managers, supply chain managers, they're constantly being hammered to reduce inventory or streamline the inventory, accelerate the flow of inventory, trend towards just-in-time inventory. So that's a common focus point. So with the data and analytics from PlanetTogether, it becomes an amazing platform to focus on continuous improvement, because a lot of companies will focus their CI activity on the inventory component of the business, because that's where the majority of their costs are. Okay, fantastic. Let's go ahead and look at the 8th waste. The 8th waste is a waste that we are advocating is the 8th waste. So again, in the world of lean, there are the traditional 7 wastes, which we just went over. But the hidden waste is the waste of setup. So as probably everyone on the call is quite familiar, when running a manufacturing operation, just to keep it very simple, you have setup and you have run. And setup is made up of components, right? There's setup, there's validation, there's test or trial, there's setup adjustment. Setup can be physical, it can be software driven like programming machines, or an aggregate of both. And that's an area where a number of companies don't truly collect data. And I guess the key question is, is setup considered in scheduling and planning within the PlanTogether APS?
Absolutely. It's one of the probably the critical component whenever you do an implementation is to be able to capture an accurate setup time, be able to simulate that within the system. So whether it be optimization, creating a schedule with minimized setup time, in addition to schedulers being able to visualize right away and let the system calculate, if I change the sequencing of these parts in production from ABC to CBA, what is the resulting setup time, and be able to show that using simulated values of the result.
Okay, so it sounds like what you're saying, the scheduling software has the ability to create what-if simulations, and different scheduling scenarios can be created to be evaluated on how to reduce setup time based on, say, families or common product types.
Exactly.
Is that what you're saying?
Exactly.
Now, that's really good to know, but I'm also thinking of it in another way. Does the PlanetTogether analytics capture setup time, actual versus standard?
Right. So like you just said now, there's a simulated aspect of here's how long we anticipate the setup will be. But the more important part, or just as important, is, well, what did it end up being?
Yes, exactly.
And so there's the anticipated, or what we call scheduled setup time. And then we also capture the reported setup time. So then through the comparative analytics of here's the standard, the anticipated versus the actual, then that in turn drives the continuous improvement effort to pinpoint areas within manufacturing where there's going to be issues with regards to setup.
I appreciate that. Thank you. What I found in my career is the number one demand of customers is lead time reduction associated with on-time delivery. And that's why I felt it was important to add this hidden waste, the eighth waste, which is setup. Because if you think of the traditional 7 waste plus setup, and we could focus a continuous improvement or lean program on those wastes, it automatically leads to reduced lead time and improved on-time delivery, which therefore is improved customer satisfaction.
Absolutely.
And this is what you're seeing with all your clients.
Right,
correct?
right. It's one workflow setup, maybe let's say a couple hours, but a couple hours there, a couple hours here, it's going to compile into great improved throughput and so forth that leads to those 2 benefits you just mentioned. So
if we, some factories assemble a continuous improvement or a lean team. Others have Kaizen events. Others, it's across the culture. Everyone has, involved role. But on the shop floor or even in the office, how can employees see how the plant is performing? Maybe there's 1 to 5 planners and schedulers in a plant, and they're creating schedules based on priority rules, or creating schedules based on different what-if scenarios, different priorities that change. But how do the employees that are producing the product or supervising the production of the product, or engineers that have to plan their time when to go out to the shop floor, or maintenance teams that need to conduct preventive maintenance, how do they know and see and become aware of really the performance of the shop floor?
So again, this being a multi-user platform, it's something that everybody can access and everybody should access in order to have a common vision of where do we stand in terms of our overall manufacturing performance, whether it be in the forecasted schedule or through analytics, that everybody can access the same piece of information so we're all in alignment as to what's happening now, what is to be expected, and what do we need to improve upon.
So are you saying that depending on the number of seats a company wants to set up, engineers or planners or a COO, they can access the information on their PC?
Exactly, and we've had many requests to have 70-inch monitors on the shop floor so that everybody can visually see anticipated setup that's coming up that we need to make sure we validate, or have a terminal on each production line so they can see the sequence or the dispatch list for the orders, the anticipated run, anticipated setup, and so forth.
So if I'm a production supervisor and I'm responsible, say, for 50 people and 4 manufacturing lines, can I have a monitor at point of use, in essence, and see what's going on?
Yes.
And huddle around it with my team and share with them today's events?
It can be served as a tool to lead your morning production meetings so you know what's coming ahead.
Okay, that's fantastic. That's a powerful tool. So let's kind of go off topic for a moment, if you don't mind, regarding analytics. Does PlanetTogether have different suites of analytics based on functional teams or leaders in an organization? So, for example, can the CFO have his set of analytics and the shop floor lead have their own?
Absolutely. And I think there's two tiers or two types of analytics that are critical. One is more the tactical, the operational standpoint. So, what are the tally of customer demands we need to satisfy? So, more the things that drive the morning meetings, the production meetings, and so forth. And then there's the strategic management level analytics that people like CFO, CEO deem very critical. So, what is the anticipated average lead time per product? What is the productivity of each resource, whether it be machines or production lines and so forth. So providing information that enables them to take action, so actionable information.
I appreciate that. The reason I thought it was necessary to go off topic is more and more companies are practicing what's called Lean Sigma. They're combining some of the concepts of Six Sigma with the continuous improvement concepts of Lean. Six Sigma being more of a data-driven approach to improve an operation and apply design of experiment and what if simulations. And what I'm learning today is the PlanetTogether analytics, in some respects, represents the Six Sigma side of things. So we can take the analytics, apply it to a continuous improvement or a lean excellence program, and hone the focus on where to apply change.
Right. So because it's data-driven, we're confident it fosters and encourages that continuous improvement culture.
Fantastic. I appreciate it. Okay, so why don't we go past the waste and talk about some other topics?
And so, with implementation of PlanetTogether Advanced Planning and Scheduling, on average, we've seen dramatic improvement in these following categories of metrics. Obviously, the very key thing every customer wants is increased visibility, and between 99 to 100% or even 120, customers get to see what is actually happening on the shop floor. Some are flattering, some might be unflattering, but it's important to see those unflattering things too. So you're now able to take actions to resolve these issues. So whether that be data or what's happening on the shop floor, sometimes the standards are what they thought they are or not. So it's all important to see that in a visualized manner, so you know what to improve upon.
A lot of, all companies, there's some level of uncertainty. Lead supervisors, managers, what have you, they might struggle with decisions because there are so many variables, and I could see how improved visibility softens the risk of uncertainty.
Right. And the improved visibility naturally leads to planner productivity because they now know what exceptions to focus on and not have to worry about checking every single item or order out there. Just focus and be proactively managing those exceptions in order to improve their manufacturing process.
Makes sense. So what else do you have as far as improvements that companies realize?
Sure. And again, the visibility really leads back to our conversation regarding inventory, reducing inventory waste. It improves inventory turns, and you're always going to have inventory. Not many companies get to be like Toyota in that they're able to procure parts same day and so forth, but certainly we have seen at least more than 50% improvement in inventory turns.
Okay, thank you. As I mentioned earlier, I just came back from a few weeks in England supporting a company in London, and the one employee that really looked worn out was the planner scheduler. This poor guy had and still has a tough job, right? There are many SKUs he has to schedule. He's working with multiple factories worldwide, and whoa, it's an unsung job.
Yeah.
So how does a APS system relieve some of the burden of the scheduler?
Being a computer software, really its primary job is to do the heavy lifting for any user out there, and a planning and scheduling system is no different in that we take all of your ERP data, but we do a lot of the heavy lifting and providing the critical information for the plan and schedule to be able to make those critical decisions rather than firefighting.
Right. It sounds to me that planning and scheduling needs to rise to the forefront and be more of the hub of information and methodology within manufacturing companies.
Right. It really should position planner and scheduler as the quarterback, because he or she will really be driving the manufacturing, what they're going to produce next. So I know that a lot of the focus on the lean has been on the shop floor, what is actually happening, how they process, but the next step, like as you said, is the lean scheduling, is to how to quarterback right so that the team as a whole can drive to the red zone and make those touchdowns.
Over the years as a business consultant, operations consultant, I work a lot with the management teams and the executive teams, and one of the common themes, challenge themes, is the challenge of risk, right? The CEO has his list of risks that keep him up at night. The CFO has his or her. The shop floor leader has theirs, and the power of the right APS, the PlanTogether system with the visuals, is information helps to reduce risk. It's common information.
Right. And I think that ultimately also ties into, shop floor productivity and on-time delivery, because everybody knows what's happening and what they need to anticipate, what they can improve upon.
Ryan introduced in the beginning that I've led the turnaround of a number of companies. You had 6 distressed manufacturing companies and 1 consumer products company, and one common theme they all had was very poor on-time delivery. One company literally had 0% on-time delivery. Another one was at 42%, and of course they were losing money. And what they were struggling to understand was, with such poor on-time delivery, their sales were declining and they could not acquire new customers or expand their sales base with existing customers. So I guess simply stated question, do you find APS is the friend of the sales team?
Absolutely, absolutely. It serves as a very good, the crystal ball, if you will. Gives them a accurate visibility into what's happening based on the open orders on the schedule, so they can tell the customers when they can actually expect, be able to make a commitment that it can actually vouch on. And as far as acquiring new orders and so forth, every question customer has, well, here's my request date, but I know you have your date, but give me a promise date you can stick with. And with a tool like this, then that promise date becomes a 100% commitment that they feel comfortable giving out.
Fantastic. The company in San Diego, the Advanced Machine Shop that I mentioned earlier, was a turnaround. And being private equity owned and a turnaround, tremendous pressure on cash flow and driving revenue into the business. And I know one of the tools that they utilized the system for was priority scheduling based on revenue. So the first 3 months of the turnaround, that's where we put our focus, was priority based on revenue to draw the cash in, and drawing that cash in helped fund our continuous improvement program. So we did not talk about CI as far as, we did not talk about APS just on, we only talked about it on the waste standpoint today, is what I'm trying to say. But it helped us in the strategic standpoint to draw cash in to help fund the CI program. So it's pretty cool. Okay, so Kinta, why don't we wrap it up now? I think we covered a lot of topics today, and we have about 5 minutes to go. So Ryan, I think we could open it up to questions.
Yeah, we got some great questions. So let me start with the first one. And it's how the Internet of Things can help advance our predictive analytics, if at all.
That's a good question. Well, let me, I don't know if I can answer that directly, but I'm not an expert on the Internet of Things. But one thing I can say is APS in a mobile platform, which PlanetTogether has, is an amazing tool where shop floor supervisors and others in the organization can be accessing reports, understanding the status of production at any time. So I don't know if that's truly an answer to the Internet of Things, but I know the information can be available on multiple devices, which helps with decision making and awareness.
And actually, now that I think about it, I have one global company. They have about 20 plants in North America alone, and they utilize PlanetTogether advanced planning and scheduling to do their detailed production shop floor scheduling. But in addition to that, that information is also used to provide the capacity planners across the North American region the accurate visibility into the delta between assigned capacity, which is available capacity for all their machines, versus the demand. So they actually don't use a laptop to access the information. They use various reporting platform like Tableau or ClickView to view that information on their smartphone as they're on the road flying across the different cities within America. So, and as far as that is something that previously we couldn't do, using our brick phone and Nokia and black and white and so forth. That's with the advent of the internet and mobile access to all this cloud information, everybody can access that information at the tip of the finger, but also be able to use that information driven by PlanetTogether advanced planning and scheduling.
I think very well said. Thank you. Ryan, any others?
Yeah, we got another one here. So can a planning and scheduling system incorporate service level constraints into the planning?
Service level constraints.
On-time delivery.
On-time delivery, right. So, I would say that there's a reality of a customer provides a request date, and sometimes that is far too unrealistic. So I think you have to start with this increments of steps. So you first start by providing promise dates you can feel comfortable giving out, and then you work towards closing that gap between customer request date versus the promise date you can give out, and eventually it gets to a point where your promise date can become sooner than the request date.
Yeah, and along with that, I think another way to really look at it is the power of what-if simulation, right? So different people interpret service level differently, but a sales team, for example, might be about to sign up a customer or sign up a particular deal, and they will need to know, well, what's the lead time to produce this? Or what's the predictability of delivering this on time by such and such a date? Certainly, the software can create various what-if scenarios or what-if schedules based on what's currently being produced, based on what's planned to be produced. So it very much narrows the gap to help provide predictive service levels,
right,
and also beyond predictive, when you're actually running the product on a consistent real-time basis, the information is completely available to know when it will be available for shipping. And then lastly, because of the priority settings can be established to focus more on service levels for particular product types,
right,
or particular customers. So it's a very much an effective tool for the sales team as well as the tactical production team.
And we have primarily two features that we designed specifically for these purposes. One is called capable to promise, and that is different from available to promise. In that available to promise is merely, I'll have this on hand, I can ship it out to you tomorrow. Capable to promise is really looking into your available capacity, all the open orders that are scheduled on the floor, and simulate, if I were to accept this customer order, when is the date that I can comfortably,
what happens?
Exactly. So being able to simulate that.
And that's the power. That's something that the traditional planner scheduler cannot do effectively in an effective time manner using Excel.
Right.
You could do all this predictive what-if analytics behind the scenes. You could adjust the priorities and really see what the results are going to be like.
Right.
Which also is not just for your plant. Those simulations can be provided to your suppliers to see if they can react. Because on-time delivery is not just tied to what you can do, it's also tied all the way down into the supply base. Can they support what you want to do?
Absolutely.
Excellent. Brian, any others?
Yeah, we actually have some great ones coming in. One here, probably Kenta, you can touch on this one, but how scheduling software can take into account sequence dependence.
Absolutely. So, we have various ways in which we capture and simulate setup. And a lot of times, companies with the ERP system, they'll have the standard setup time, but that doesn't take into account the way in which orders are sequenced. So we have a functionality that we essentially call attributes. So based off of multiple attributes, then you can kind of see the before and after for each of those attributes. and say, well, from A to B, it's half an hour. However, from A to C, it's going to be 45 or 60 minutes and what have you. So we can capture all those attribute changes and create a, well, many people can call sequence-dependent setup, and schedule in a way that minimizes that the implicating setup.
Fantastic. Ryan, since you have more questions coming in, let's keep going. But I don't think we have to constrict the time.
Yeah, I think we've got a couple left, so let's keep doing. Let's see. Let me let's go through here. Let's see. What features are included in the free trial reports? What are the ways to optimize the schedules? What if scenarios, etc.?
Sure. So the standard analytics we offer are all available out of box. Things like on-time performance by work center, machine, departments, or your entire plant. It could be average lead time by part. It could be, in essence, your capacity availability across your work centers based off the demand versus assigned. And just in general, your on-time delivery performance. Not just looking at the operation level, but at your customer level. And we have other analytics like predicted or forecasted revenue production plan. So in other words, based off of the work orders or production orders with the revenue attached to it, based on the schedule dates, you get a visibility into, okay, for the month of June, we're predicted to produce 10,000 units worth, let's say, 1 million. Now, the July could be we're only producing 5,000, but because of the premium, we're able to produce twice that amount.
Right. I think it's a great question, and Kenton, you might want to take a few seconds and briefly describe the trial process, because I think it's important to note that at the start of the trial process, as the relationship is building, PlanetTogether is assessing the customer's needs, and the real data is loaded.
Right.
And there's a lot of education with regards to the APS that's taking place during the trial process, and analytics that can and will be provided so they can understand how the needle is being moved in the positive direction.
Right. The key objective with trial is that it's hard to make an investment into a system like this without really being able to visualize what the solution and the benefit is going to be with your data that you're familiar with. So through the trial process, we really work with each customer to connect to their ERP system, or simply work with them to provide the raw data. A lot of times, even if they don't have an ERP system, a lot of this data is captured on a spreadsheet. So we can integrate to a spreadsheet as well to bring that data into our system, get a basic model up and running so they can visually see what the solution is going to look like.
Fantastic. Thank you.
Yeah, so an interesting question here is, with the eyes towards the future, is APS ready for the additive manufacturing in general, specifically in the 3D printing area? How do you foresee scheduling software impacting that area?
Well, I'm no expert on this, the 3D printing manufacturing, so I'm going to have to refer to you on this one.
I'll take that and see if I'm in alignment with the person asking the question. 3D printing, in essence, is another type of machine, right? So if you think of a number of manufacturing plants that have automated machines, they might be robots, they might be CNC machines, machines that are computer controlled, injection molding or blow molding. The bottom line is, for a machine, whether it's 3D printing or a CNC metal machining machine, to process its product or the product through it, it's all based on scheduling. It's based on priorities. It's based on customer demand. I'm going to repeat that a little different. It's based on aligning customer demand with supply, what you can produce. It's based on sequencing. It's based on process times. It's based on setup times. It's based on run times. Even 3D printing needs resources assigned to it. Something we didn't touch upon today, but we certainly will in future webinars, is the power that APS contributes to plant maintenance. machine and equipment maintenance. 3D printers will need maintenance. They need setup. Also, materials need to be delivered to the 3D printers. 3D printers need to be stopped to pull off the product and set up for the next one. So I guess if I'm understanding the question, it's just another machine. APS can be applied to facilities that are labor intensive and can be and is applied to facilities that are heavily machine laden or process laden. And I think this is going to go off on a slight tangent, but Kenta, you might want to take 30 seconds and share some of the applications you've personally led that are not labor intensive, such as food and beverage that are process oriented, but they still have to be scheduled.
Right. More importantly, because let's say take packaging industry where they do a lot of offset printing and so forth, they need to take into account, when a die changes or the mold changes, that's a setup right there. Especially more critical is when the ink changes, they have to do a lot of that simulation of, okay, we're using 7 colors consistent of red, blue, magenta, etc. Okay, now we're about to go print something else that may consist of black, blue, turquoise, and so forth. So, this is all machine scheduling, but there's a lot of that setup calculation that we have to go into and making sure that we have the right amount of materials ready so that those print presses can be busy running.
Yeah, thank you. Very, very well said. So I hope we answered the question. If not, fire off another one and we'll go at it.
Yeah. And in regards to food and beverage, also, that's another critical thing, things like allergen. If you ignore that, that's going to be a huge risk factor when it comes to planning and scheduling. So we do a lot of the sequence-dependent setup based off of what allergens are being used for a particular production run, or when you're running a batch of a particular food group, moving to another one. So if it's, if you're using peanuts or almonds, etc., those type will not serve as especially critical.
Thank you. And the reality is APS is applicable to all industry sectors and should be applied to all industry sectors regardless of the machine type or the labor loading. It's all about optimization.
So I think we're out of questions.
Okay.
If you want to go to the next slide, Kenta. But I'll leave it up to you guys if you want to make some closing remarks. But I just wanted to tell everyone that we've got Bob and Kenta's contact information on this slide, and feel free to contact them with any questions afterwards.
Yeah, I think I'd like to make a quick few closing remarks. Again, back to the lean timeline. For many years, companies have been practicing lean in what I call the traditional physical manner. 5S programs, spaghetti diagrams, physically and visually changing shop floors, changing flow, changing the layouts. But the new paradigm that is making tremendous inroads is realizing the impact of transactional lean, but more importantly, realizing the hub, the central nervous system of a manufacturing plant is scheduling and planning. In order to really optimize your inventory flow, your cost of inventory, your labor resources, how and when to schedule maintenance, collect data to make the right informed decisions, you need the right schedule. And you need some schedule compliance. That's what a number of clients of mine talk about is how can you help us get schedule compliance? Without schedule compliance, you can't achieve service levels, shorter lead times, reduce costs, and improve cash flow. So in conclusion, the new lean paradigm is applying APS to your manufacturing environment.
And add to that, we feel comfortable that we have a solution that can really help manufacturers achieve that vision. And so, as a software company, but also as a service provider, we're very proud of the solution that we have in place, and we, very much look forward to working with more manufacturers around the world.
And lastly, I want to thank all the participants for sitting through what wound up being a 55-minute webinar. We usually schedule them for about 45, but due to the demand and the questions and the number of participants, we decided to run over. So thank you, and phenomenal questions.
Yeah, thank you, Kenta and Bob. Thank you, audience. And you'll all be receiving a recording of this webinar later on today. So have a good day, everyone.
All right. Thank you.